Shall I start? You through the brief walkthrough of Android, like what exactly is Android and how do we develop an application in Android. So let's see what exactly is the agenda that we follow here in order to go through the session for today. Here is the flow chart, like how exactly are we going through for this particular session. We'll first see what is Android, what exactly is Android, and how we people think about Android and what exactly it is. And next one we go about is Android evolution, wherein we see what exactly are the versions that have come in Android and how the Android is evolving, what are the new versions, what are the new features, and how it is developing and how it is going to develop in future. That we see in Android evolution. And after that we'll be going through the Android architecture, how exactly Android is designed, what exactly are the OS languages used in Android. So we'll see the Android architecture, how exactly the Android has been developed. Then we'll see an Android sample application, like how exactly we need to develop a sample application and how we need to push it into the device. This kind of a hello world application we can say. Okay, we'll develop a small application and see how does it work, and we'll see what exactly are the software components needed to develop an application, what exactly are the hardware components that are required to develop a sample application. We'll see how exactly we can develop a sample application. Then we'll see what exactly is the Android life cycle, means how exactly Android activity life cycle. I'll come to this particular activity life cycle at a later point of time, because we exactly need to know as a fresher, like we don't know anything about Android. We should know exactly like how exactly Android, the screen of an Android works, how do we develop it. After that we come to Android activity life cycle. What exactly is the Android activity life cycle? So I will come to that at a later point of time. And in the end we'll see how do we port an application onto the device. So in total, we'll start with what exactly is Android. I'll repeat what exactly is Android. We'll see, okay, and then we'll see how exactly Android has evolved from the beginning until now, and how is it going to be in future. We'll see that, and we'll see Android architecture, how exactly the layers of Android OS, like how exactly the Android is designed, okay, and which part of Android deals with hardware, which part of Android deals with software, what is the middleware. We'll see in Android architecture. Then we'll see an Android application, sample application. It's a small application. If you want, you can put that particular application in the Android market too, and you can put that on your phone. You can run that on your Android simulator, everything. We will see the Android sample application. Then we'll see life cycle, and after that we'll see how do we port, how do we push an application onto the device. So going to the next slide, what exactly is Android? Many people think it is kind of an operating system. Many people think it's a kind of software. But let's know what exactly is Android. Android is a Linux-based operating system designed primarily for touchscreen mobile devices, the smartphones and tablet computers. Okay. Initially developed by Android Inc., whom Google financially backed and later purchased in 2005. So Android basically it's not a new OS or something. Android is developed using Linux software, Linux operating system. So inbuilt there is Linux operating system. Okay, this is not completely new operating system also. Android has got a Linux base. On basing on Linux, these people have developed multiple layers which can interact both with hardware as well as the user at the same time. So Linux is the basic operating system that has been used, and Android is primarily not a product of Google. It was developed initially by Android Inc. Then Google has financially backed that particular company, and finally Google has acquired that particular company in 2005 and finally made Android as its own. So basically Android is not Google's company. Okay? Google has finally acquired it. Android is completely a stack of OS, middleware and application. So we generally should not have a misconception that Android is completely an operating system. No, Android has an operating system which is Linux, but Android is not completely operating system. Android is a trio, you can say. It's a trio of operating system, middleware and applications. Basically, we would be working on the applications front here, this applications front, and we would be developing the applications. Uh, and this OS and middleware are already well in place, and we did not disturb any part of this particular thing. And if we want to develop an application, port on the device, publish into the market, then we'll be working in this particular layer called as applications. So Android is a trio of stack which contains OS, middleware, applications. We'll see what exactly these three categories are in the Android architecture slide. So let's just have a vague idea that it's a trio of three terms combination. Okay. Next, let's go to how exactly we develop an application in Android. So we have seen the operating system in Android is Linux, but in which particular language we do develop a program, say a program or an application in Android. We'll be developing an application in Java. So in order to develop an application in Android, we basically must be knowing the concepts of core Java and the object-oriented programming structures like the OOPS concepts. OOPS concepts and core Java are very much required in order to develop an application in Android. So this is not a big tough deal for anyone to learn the core Java. It is a normal programming language which anyone can pick up in say of about 30 days or so. In the meanwhile, when we learn Android, we can automatically learn the core Java too on the sideways, and I'll take you through that. So next one is open source and the Apache 2 license. What exactly is open source? Let's compare Android and iOS. If you say iOS, everything, if you want to develop an application, if you want to code the application, if you want to put this application to the App Store of Apple, everywhere you need to pay some amount of money. It's not an open source. You can't download from the internet and put into the market just for free as you need. But here in Android, everything is free. You did not pay for anything. It's an open source under Apache 2 license. So if you want to download, the software for say SDK or anything, if you want to download the Android SDK for the application development, or if you want to publish your application into the market, everything is free. But the only place where you need to pay for an Android application is when you want to publish your application. If you want to put your application into the Google Play Store, the market, it's only a one-time fees of $25 that you need to pay. If you pay a fee of $25 for your account, you can publish as many number of applications as you want into the market. So I hereby close this particular slide. What exactly is Android? So we have got an idea that Android has three layers. The bottommost one is the OS, the Linux-based OS. The middle one is the middleware, which interacts with hardware and the application software, that is the middleware, and the topmost one is the applications layer, which we would be developing in a short course of time. I'll go to the next. How exactly the Android has evolved? What is the first version and how exactly it has it's keeping on evolving, and what are the new versions coming in? The first one that started with is Cupcake, and they have given the version name as number as 1.5. From 1.5 they have gone to 1.6, 2.0, 2.1, 2.2, 2.3, 3.0, 3.1, and 4.0, 4.1, 4.2. 4.2 is the one that is going on as of now. If you could see some sort of feature that they are following, if you could see the names of all those particular versions. The first one is Cupcake, second one is Donut, third one is Eclair, fourth one is Froyo. If you could see the initial letters of all those particular versions, the first one is C, next one is D, E, F, G, H, I. So they are kind of following an alphabetical order, wherein they started with C and they are going till I, J, K, L, M, and O. They want to continue that way. The Android names would be evolving that way. If you could see the ice cream sandwich, it is 4.0. In fact, I have not mentioned the number over there, but it is 4.0, the ice cream sandwich. And after that, they have released Jelly Bean. It is 4.2, Jelly Bean. It starts with J, I, J. And the next one that we are waiting for is something with K, which Android has not yet released. And mostly it will be released with a name starting with K. So this is how the names of the versions of Android keep on going on. It started with Cupcake, Donut, Eclipse, Gingerbread, Honeycomb, Ice Cream Sandwich. So what exactly are the major differences, if we can say? There are minor differences between this 1.5, 1.6, 2.0, 2.3, 2.2, 2.3. Up to 2.3, there are minor releases. We can say these as the minor releases when no much big features have been changed. But coming to 3.0, Honeycomb. This Honeycomb was basically meant for developing applications in Android tablets. Android tablets are something which are the counterparts for the Apple's iPad. If you see the iPad, if you want to have something of the same sort in Android related devices, you have Android tablets. Android tablets have been manufactured by many companies, Sony, Lenovo, and many other companies. Even Amazon has to come in. We have many companies which have. Samsung is the major market capture for the tablets. Samsung Galaxy Tab. And many more tablets which start from 7 inches to 10 inches, 13 inches. There are many big tablets out there in the Android market. So all these tablets will be using the version of Android 3.0, the Honeycomb version, which is exclusively designed for Android tablets. And this particular version of Android OS would be pushed into the Android tablets. And again, the Android 4.0, 4.1, all these are made for the phones. So if you could revise this particular slide again, 1.5, 1.6, 2.0, 2.2, 2.3, up to 2.3, these are meant for the phones. This OS is meant for phones, and 3.0 is exclusively meant for the tablet. And after that, 4.0, 4.1, 4.2, again these are after 4, these are meant for the phones again. So if you want to design application in tablet, go for 3.0 version of Android. And if you want to design an application for the phones, you can start from 4.0 or 4.2 for the latest version of Android. Hereby I will be closing this particular slide and moving on to the next slide. Let's see what exactly is the Android architecture. If you could go with this particular one, it seems to be too huge an architecture, but it is very simple and easy to understand for a layman too. And I will guide you through this particular slide. The bottommost one is the Linux kernel. If you could see, the Linux kernel is the bottommost one, and this particular layer of Android OS, it interacts with the hardware of the device. The basic intent of using the Linux has come from, like, if you want to port your application, if you want to run your software, if you want to run your Android OS on any particular hardware, irrespective of the configuration of the hardware, if you want to run it on any platform, Linux is such a platform which has got no restrictions. It's an open source and it can interact with any sort of hardware. So having that particular intention that your Android operating system should work on any hardware, the Android team has put the kernel in Linux. They did not go for any sort of other operating system, unlike Apple iOS. If you could see, Apple iOS does not use any sort of this sort of open source, open operating system. That made it very much conservative, very much reserved. It does not work on any other devices. If you want to develop an application in Apple iPhone, if you want to develop an application for iPhone, you need to have a Mac machine. Without a Mac machine, you can't. You should have a MacBook Pro or a Mac machine or something related to the Apple itself in order to develop an Apple related application. If you want to deploy it, if you want to see any sort of Apple related things, you can't put on any other phone. But coming to Android, as it is using the Linux kernel, as it is using the Linux OS, you can push it onto any sort of hardware without any sort of restriction, as it can interact with any sort of Android, any sort of hardware platform. So we'll see what exactly are the things that are present in Linux kernel. In Linux kernel, we can see all the things are the drivers. What exactly are these drivers? If you want to interact with any sort of hardware, you can see the display, the camera, the Bluetooth, the flash memory, power management, binder IP driver, keypad, Wi-Fi, audio, USB, all these things are hardware related components. So if your software has to interact with this particular hardware, you need to have something called as the driver, which could interact, which could act as a middleware between your hardware and your application. So this particular Linux kernel, it in fact acts as a driver between your, let's say if you take a Bluetooth component, it acts as a driver between your Bluetooth hardware and your Bluetooth written programming. So this Linux kernel, it acts as a middleware. It acts as a middle thing between your application and your hardware. This is the Linux kernel. And next I'll be going to the and this Linux kernel is completely written in C and C++. Okay. Next I'll be going to the libraries. What exactly are these libraries? If you could see, the intention of putting this in this particular green color is it is written in C and C++. And the intention of putting this particular application framework in blue color is it is written in Java, core Java, it is completely Java. Everything that is put in blue color is written in Java. These core libraries is written in Java. This green color particular one, it is written in C and C++. We'll see what is this particular libraries. So basically going to Surface Manager. The Surface Manager is a library which is written in C and C++. What exactly it does? If you could see your Android phone, there will be many sort of windows coming one on top of the other. It organizes all the windows. If you could see, there will be multitasking. The basic purpose of a smartphone is to do the multitasking. All windows, you can open one window on top of another one, and all of them would be placed on a stack. Okay, so all these windows and all the windows will be, in fact, what exactly happens is this will be painted on your screen, pixel by pixel. This will be painted on your screen. It's not a kind of inbuilt components. Also, each of them will be painted pixel by pixel on your screen. So, painting all these sort of windows and everything, painting whatever you see on your screen would be managed with the Surface Manager. This particular one manages all the things that you are seeing on the display. Next, we're going to the OpenGLS and SGL. These are exclusively the components, the libraries would be dealing with the graphics. If you are developing any sort of gaming application, then you would be needing all the graphics related libraries in your application. So the graphics related libraries would be rendered by the OpenGLES and SGL libraries of the Android framework. Next one is the media framework. Media framework is used basically to create all sort of media related components, be it a video component, be it an audio component, be it some sort of MP3, MP4, whatever .mov, whatever format you have got, whatever movie you have got, whatever audio file you have got. If you want to play it, the media framework would be useful, and it would be playing you all the sort of media related things. And free type is basically used for the font related things. You want to support all sorts of fonts by the Android system. If you want to see all sorts of fonts and different sort of, say, Times New Roman, Verdana, whatever it is, what sort of font you want. This free type is a library which gives you all the font related things. Next one is SSL. SSL stands for Secure Socket Layer. If you want to deal with any sort of banking related applications, then the complete browser would be redirected to a secure region, secure sort of web URL redirection. You can say the HTTP in the web URL changes to HTTPS. Okay, that particular thing, secure socket layer related thing would be rendered by this particular library. Next, go into the SQLite. What exactly is SQLite? It somewhere reminds you that it's something related to SQL. Exactly. This SQLite is something which is related to the database. SQLite has got a minimum memory management footprint wherein it makes use of very little memory, and using that particular least memory footprint on your device, it manages all the database related operations. You can save, you can add rows, delete rows, add columns, pushing data, whatever you want, whatever you do in normal RDBMS, the relational database thing, you could put everything in the SQLite. So next one is WebKit. What exactly we do in WebKit? WebKit is an open source web browser kit. Any Android smartphone you take, you'll be having an you'll be having a browser, inbuilt browser. So this WebKit is an open source browser which provides all the browser related functionalities to you in an Android smartphone. Leaving this particular basic browser that we can install any sort of other browsers too on your Android smartphone, be it an Opera browser, be it a Mozilla, be it a Chrome, whatever you want, you can download all those sorts of browsers for sort of browsing purpose. And libc is meant for a library in C, which is basically used for linking all these libraries which are discussed: Surface Manager, OpenGL, SGN, Media Framework, FreeType, SSL, STL, all these things would be linked by this particular libc. It is a core library in C which links all these particular libraries together and forms the library core framework of Android. So hereby we have completed the Linux kernel and the libraries of Android architecture. Next one, let's go to Android runtime. What exactly is Android runtime? Android runtime has basically two components: dynamic virtual machine and core libraries. What exactly is dynamic virtual machine? Let's go to Java. What exactly is the virtual machine used over there? We'll be having something called a JVM, Java Virtual Machine. Java Virtual Machine is basically used for converting your Java classes into dot class files. These dot class files are the binary code formatted files which directly interact with your hardware. Okay. The Java files, the normal Java which you have written, is not understandable by the hardware. The hardware cannot understand your Java files. So there should be some sort of a file which should make the hardware understand like what exactly is the one which the user is trying to speak with the hardware. What is his expectation? What is he trying to develop? So there should be some sort of binary and hex code, binary, we can say binary coded format file which the hardware can understand. So the Java Virtual Machine JVM converts your Java files into dot class files. Java files into dot class files, and those dot class files would be understandable by your hardware. Here in Android, we are going dynamic virtual machine. You will write Java code in your .java files. These .java files would be converted into .dex files, DEX. The Java files would be converted into .dex files, and these dex files are understandable by the Android hardware. So, there in Java we'll be having .class files, but here in Android we'll be having .dex files. These .dex files are understandable by the hardware. So the dynamic virtual machine, basically its job is to convert the .java files into .dex files. So basically this is the Android runtime, and this so our software created in Java would be understandable by the hardware of the Android smartphone. Next, let's go to the application framework. This application framework, this particular component, I would be taking it over after we complete the development of some sort of basic applications, without which we cannot understand like what exactly is the application framework. This application framework, each and every component is a separate topic which needs to be dealt with in different class, and each particular thing, each particular component needs an example to understand. So here in application framework, at this particular point of time, it's not the right time to deal with this application framework point of architecture, and I would be dealing it with after completion of some sort of syllabus, and we'll be dealing with the applications too. So these two particular components, it's not the right time to discuss at this particular juncture. So I'll be dealing it with after completion of some sort of topics later on. So I'll be moving on to the next slide. How do you develop a sample Android application? What exactly is it? How do we develop a sample Android application? I'll show you like how exactly we do that. I'll show you like what exactly are things, what are the system requirements, what are things needed. Like if you want to develop an Android application, what is the system configuration that you need? The system configuration that is needed is Windows XP 32-bit, Vista 32 or 64-bit, Windows 7 32 or 64-bit, And you can, the best feature is you can develop an Android application on the Mac OS too. If you're using a Mac machine, you can develop your application on Mac OS. You can develop your application if you have a Linux-based system, it's Ubuntu or Linux. You can develop that particular on that particular machine too. And if you have GNU-C library, if you have Ubuntu Linux and 64-bit distribution is capable of running 32-bit. Okay, if you have 64-bit machine also it will work. If you have a 32-bit machine also it will work. So this is the basic system requirement. Your system should be of this particular minimum configuration to put your Android application, run it, and whatever you want to do. And software requirements. The installations part I will not be taking it. The installations I will not be dealing here with completely. Like what exactly are the installation, how do you install something else. In the real-time class I will be taking like how exactly you will be installing your Android related software. Installing the correct version of Eclipse is essential. You should have a right version of Eclipse. Eclipse is an IDE, integrated development environment, wherein Eclipse is the one wherein you put your Java code and you develop your application. So Eclipse is the IDE. Android's documentation assumes you already have an Eclipse IDE installed. Eclipse Classic Helios 3.6.2. This is the version. Eclipse Classic Helios is the version. Eclipse Classic Helios 3.6.2 or higher is required to run the Android development tools. So it's better if you have a 4 GB RAM. 4 GB RAM is preferred because Android simulator is pretty much slow. Simulator is the one which completely apes your device. If you don't have a device with you, you will have something called a simulator in your machine, which almost it gives the feel, it gives the feel of usage of a device. So that simulator is very heavy on the memory, on your RAM, so it makes your PC very slow. So it is better you have, it is always advisable that you have something, a RAM of 4 GB or above. So better you have 4 GB or above RAM, and anything less than 2 GB will make this development very slow. So 2 GB is kind of, it's okay, but 4 GB is preferred. Better we should have a 4 GB RAM. So we'll see how exactly we develop a normal application in Android. As I said, Eclipse is an IDE, and in this we will be developing, this is the heart and soul of our Android application, and here we will be developing our Android application. Let's open this Eclipse. Yeah. We'll see how exactly the project is organized in Android. Where exactly we need to place our files and how do we write a sample application in Android. Here, what we'll see is all the code related, all the Java related code will be placed in SRC. SRC, this is the source. SRC is the folder. Here, if you could see my mouse, SRC is the folder where all the Java related code will be placed. If you want to write anything in Java, the code logic of your Android application would be placed in SRC folder. Coming to the next folder, this is Gen, Gen. As its name already states, it is generated, automatically generated Java files. All the Java related thing, this is automatically generated. If you could see this r.java, this particular file, everything, whatever variable that you create in your application, whatever name that you see, if you could see hello world, integer, app underscore name, all these things would be given a unique hex related number, a hex digit number to each and every particular variable that you have declared. A unique hex code would be given. You are not supposed to modify any of these particular hex codes. We are not supposed to modify. This is an automatically generated thing by the Android virtual machine, and it should be left as it is and nothing should be modified. Okay, this is automatically generated thing, and we won't be using any part of this particular gen folder. This is exclusively meant for the Android framework only. We are not supposed to do any sort of changes in the gen folder. So whatever we want to write the Java code, we need to put in this SRC folder, and we'll be putting all the Java files over here. Android 4.1.jar. This is the basic Android library which gives an Android related functions, methods and everything. So we are including Android 4.1 over here. Android dependencies are the one where we can see all the Android lower versions. Here Android 4.1 is put over here. If your application has to support the lower versions of Android 2, here we'll be giving all the jars that are present or that are required for the lower versions compatibility. If your application has to work on an Android 1.6 device, if your application has to work on Android 2.1 device, if your application has to work on Android 2.3 device, then we need to give the support, we need to give the dependencies for the lower versions of Android 2. So here we'll be giving all the versions support which is required for the lower versions of Android. And I come to the assets part later on in some other application. And bin, what exactly do we have in bin? See, if your application is developed, your application is completely developed, so how do you give your application to someone if he or she wants to see your application on the phone? You need to give some particular file which he or she can run on their phone. What do you do? How do you do that? Your application contains a file called as .apk file, application packaging file. This APK file is the end product of any sort of Android application. To whomever you want, be it Android market or be it some individual, be it a customer, be it a client, whomever you want. If you want to give an Android application, you need to give your .apk file. That is the end product of your Android application. This .apk file can be put on any particular Android device, and he or she can run that particular APK file and he can see the application running. So this .apk file would come in this particular res folder. If you go to the bin, if you go to res, there will be an .apk file. This .apk file is the end product of any sort of Android application. And I'll be coming to the Android manifest too in some time. What exactly is the Android manifest? As all these smartphone applications are image related, are UI related, are rich UI related, we'll be using many sort of images in our application. All these images would be placed in res folder, HDPA, LDPA, MDPA, XDPA. What exactly are these? HDPA stands for high density pixels, LDPA for low density pixels, MDPA for medium density pixel, XHDPA is the extra high density pixel. So what exactly does this mean? Based on the density of your picture, you can place your pictures in these particular respective folders. But what is the need? What is the need for having these many sort of resolutions? All the Android related devices are not of same resolution. Each and every device has different resolution. Some have the high density resolution, some have the low density resolution, some have the medium density resolution, and some have extra high density resolution. Absolutely the high end Android phones. If you go for Samsung Galaxy S3, if you go for Samsung Note 2, they have extra high density pixel resolution, the AMOLED display. For those reasons, your images in the application should be complete with extra high density pixels. So any images that you'll be using in your application, if they are of that particular extra high density pixel resolution, they should be placed in drawable -XHDPI folder. In the same way, if you're using a medium density one, then you should be putting it into the MDPA. And in that particular way, all the images should be organized in the RAS folder. And coming to the layout, what exactly is this layout? So how do you design your UI? There should be some sort of format as how you design your UI. So basically UI is designed in XML in this particular Android. So how do we design it? If you could open this activity underscore main. Just a second, it is opening. Yeah. This is the basic XML thing. Okay. This is the XML one, and here you are supposed to design your UI. If you could see the graphical layout, you'll be having all the you'll be having all the controls. So here you'll be having button and everything. You can directly drag this control onto this particular screen. You can drag and drop the controls. You can completely design your UI in this particular XML. And here this is the control. This is the complete user design. Then you can just text fields, layouts, and everything, whatever you want. You can drag and drop those things as in sort of .NET or any other language. You can just drag in and drag out, or if you want about the dragging particular technique, you can directly write the code over here in XML. If you're proficient in XML, you can directly write the code over here, and you need not drag and drop. Here in our sample application, I'm just using a text view. Mean to say, I'll be showing a hello world. Hello world would be displayed on your Android phone on the screen, nothing more than that. Here I'm using a text view. And after that, here is the basic structure, and I'll be going to the Java code. What exactly I'll be doing over there? This onCreate is a function. OnCreate is the function which is the starting point of any sort of Android application. If your application has to start, it will come into the onCreate. It will start from here, and it will set content view. What exactly it is? Set content view tells the application which particular XML file in the layout folder. This is the layout folder. You can have multiple XMLs over here. An application can have multiple screens. Multiple screens, in fact, turns it into multiple XMLs. If you want to have a screen, have an XML. Design your screen in the XML and put that XML in the layout folder. So when your application starts, it should know which particular XML it has to pick up, which particular screen it has to show. Then here we'll be giving the set content view. This particular line of code tells the application that here, look, we need to take this particular XML from the layout file and we need to show it over. And this set content view sets the context that this particular layout should be shown. So we are not doing anything more than that, and we'll see like how exactly we run the application. As I've already said, we'll have something called as Android Simulator. This Android Simulator is the one which completely gives a look and feel of your Android device. So I'll start the simulator now. As we don't have the device now, I'll start the Android Simulator. If you would see AVD, Android Virtual Device Manager, and this is for Android 4.1, and I'll start it. As I said, this is completely very memory resource intensive one, and we are supposed to have 4 GB, that is preferable, and you could see its performance on this particular laptop. It's a 4 GB one, but still it will be somewhat slower. You can imagine how it could be on a 2 GB or 3 GB or something less than 2 GB. Let's see how exactly it goes. If you could see, this completely gives the scenario of a phone. You can feel that it's your phone or something like that. So it's called as an Android simulator. It's starting, it will take a couple of minutes, and let's see. Sorry. Yeah, here comes your phone. It's completely your phone, we can say. And you can unlock your phone over here. I unlocked it. I unlocked the screen. And this is your phone. This is your phone. You do not have your physical phone. You can do what all you want on this particular thing. So as you have your phone ready, it's time to run your application on your phone. So this is the demo application that you have designed. Just right click on it and go to run as an Android application, and it will run directly. It will start running on the demo application. You will see the program over here. You would say, hello world, here is your application, here is your phone, and your phone, the application that you have designed has come on your phone. Okay, if you physically connect your device, if you physically connect your phone to your Android to your laptop or to your desktop machine also, the procedure would remain the same. Just connect your device to your laptop, right click on it, click as run as an Android application. It will directly push the application, push the APK file which we have already discussed on your phone, and in your phone you can see your application running. If you could click the home button on your phone, it will take you to the home screen, and there's the applications list icon where you can see all the applications. I click on it, and here I see all the applications, and here is the main activity application that we are designed to. If you click on it, your application would be shown. It's something as like you download some. If people laymen do download all the applications from the market and open it, but here we can design our own application and put on your device. You have your icon, you click on it, and you see your application running. That seems so good. So this is how we run an application onto the device, onto the simulator, and this is the simulator. And if you could revise it, like what exactly we have done, we'll have a Java file, the basic, the complete heart of it, the complete heart of your application. There's a Java file, and after that we have the XML file. We have an XML file here, activity underscore main.xml. This designs the UI of your application, and after that what we have is the resources, the Android manifest file. I'll tell you what exactly is the manifest. And if you could open this particular RES file, I'll show you, like I have already discussed, where exactly this APK file resides. If you could see, resource underscore APK. about 19.5 KB. It is very, very, very low in the memory front. Okay, this resource underscore dot apk file. This is the final deliverable that you give to any sort of client or customer or your Android Google Play Store or the market. So this particular APK file, put it on any particular device, just double click on it, you will see the application installing, running and everything. So this is the basic complete output final deliverable of an Android application. So this is how we develop an Android application and have seen this particular thing running on our device, and the inbuilt things will be seen in all the detailed things we'll be seeing in the detailed class, and this is the basic demo of how exactly your Android application works. Vijay, thank you. It's done.